Hi everyone, and welcome back to a new video about IB Math. In today's lesson, we will be solving this important question, which is about Trigonometry Paper 1 for the IB Math AA High Level. Now, this is really genuinely a useful question if you are preparing for any IB Math exam at school or the actual IB exam, because it's really rich with ideas that we will learn from here. We will learn how to use many trigonometric identities, and here how to solve trigonometric equations, which is, as you know, this is trigonometry topic 3 in the IB Math. After that, we will learn how to link the topic of trigonometry here with polynomials and their sum and the product of roots, which is completely different from trigonometry. So this is a section B style question where really many students struggle here because some questions like this link different areas of math or IB math together. So we will start now with this. We need to prove or show the identity here. We have sine 3 theta equals to this. Now you know that in trigonometry we have really lots of identities, but none of them is directly about 3 theta. So to solve this, which identity we will use here? We will use this compound angle identity sine A plus B. Now you might say, but here we don't have A plus B, we have just 3 theta. Of course, we'll make it sum to use this formula. Here we'll use, by the way, the plus, not the minus case. So how do we solve it then? We'll start here. Part A. Here, as you see, we have sine 3 theta. We'll start from the left side till we reach the right side. So here, sine 3 theta is equal to, of course, we can write, as you see, 3 theta as 2 theta plus 1 theta, which is still 3 theta. Now, compare this with this here. So we'll use this formula. We'll consider A to be 2 theta and B to be 1 theta. So every A here will be 2 theta and every B will be 1 theta. So as you see, we'll start with sine A, which is here sine 2 theta. Then cosine the angle B, the second one, which is this here, theta. So cosine theta plus, now the opposite, we have cosine 2 theta multiplied by sine 1 theta. Now we are done with this. Here, after we expanded, you see that we still have cosines. But here we don't have any cosine, which means we have to eliminate all the cosines. Another issue. Here, as you see, all of the angles are just theta. See here, theta, theta, like 1 theta in each. But here we have 2 theta. And here we have 2 theta. The only way to change from 2 theta to 1 theta is to use double angle identities. That's why here we'll use the double angle identities, and luckily all of them are given in the formula booklet. So here now, I'll put them here. See now here, equals here, the sine 2 theta will be replaced by this. So I will write 2 sine theta multiplied by cosine theta plus, I forgot, by the way, here, look, I replaced sine 2 theta by this, direct substitution from this formula. But don't forget, we still have multiplication by this cosine, so times cosine. Then, here we have plus, so now here plus. Here, as you see, we have cosine 2 theta. Because I need only sines, so I replace the cosine here by sine. Look, I will use this identity that cosine 2 theta is equal to this. I need only sine. So I will replace the cosine 2 theta by 1 minus 2 sine squared theta. But don't forget, after the cosine, we still have multiplication by another sine. So here, sine theta. Now this could be written now like this, 2 sine, here as you see, cosine times cosine will be just cosine squared theta, plus Here we'll expand the bracket. I multiply 1 by sine, which is sine, then 2 sine squared by sine, which will be 2 sine cubed. So here, 1 multiplied by sine, 2 sine squared by sine will be 2 sine cubed theta. Now, one problem left. Here we have cosine. All of them are fine except for this cosine squared. You know that from the Pythagorean identity, cosine squared is 1 minus sine squared. That's why I will replace the cosine squared here. So 2. I will replace the cosine squared by 1 minus sine squared theta plus sine theta as it is, then minus 2 sine cubed as it is. Then expand the bracket. 2 sine theta by 1 will be 2 sine theta. 2 sine by sine squared will be 2 sine cubed theta. Then plus sine as it is, minus 2 sine cubed as it is. Here we can group 2 sine theta plus 1 sine theta will be 3 sine theta as we need here. Then negative 2 sine cubed, another negative 2 sine cubed will be negative 4 sine cubed. So which is equal to 3 sine theta minus 4 sine cubed theta, which is what we really need to prove. So with this, we did part A. Now, for part B, it says, hence solve this equation. Now, you need to know something very important. Here they said hence, which means we have to depend only on what we did in part A. And here, it's the skill of solving trigonometric equations. Now, see here, do you have any similarity between this and this? Here, look. So now, we need to solve this. Look, I will move the 4 sine cubed to the right side of the equation. So we will have 3 sine theta minus 4 sine cubed. Why? It will match this perfectly. So now, if I move it, by the way, if I move it here, nothing will be left, only 0. So here, I will write for part B. For part B, as we said, if we move here 4 sine cubed to the right, we'll have 3 sine minus 4 sine cubed equals 0. So 3 sine theta minus 4 sine cubed theta is equal to 0. But of course, it's very hard or long to solve this. Instead, smartly, we'll use part A. We will replace all of this by sine 3 theta as we proved. So here, this will be replaced by sine 3 theta equals 0, which is now very simple. Look, before you solve any trigonometric equation, you have to be aware what the domain is. See here, theta is between 0 and pi, or like 180 degrees, but this is theta. Here in the question, as you see, we don't have theta, we have sine 3 theta. So that's why if theta is between 0 and pi, when you multiply it by 3 everything, 3 theta will be between 0 and 3 pi. So 3 theta will be between 0 and 3 pi. So now we'll solve. When sine is 0, what is the angle? You know, by the way, from the unit circle, the sine axis is this. Sine becomes 0 here when the angle is 0, or here when the angle is 180 degrees, or here pi, since we're dealing with radians. And then back here, another one, so it's 2 pi. And back here again, if we go like half a circle every time, we will have 3 pi, then 4 pi, 5 pi, and so on. But here we'll stop only up to 3 pi. So now here, Here, as you see, we have 4 solutions, as we saw in the circle. 3 theta could be 0, or it could be pi, or it could be 2 pi, or 3 pi. Now, these are 3 thetas, by the way, so now we have to divide all of them by 3, each one of them by 3 to get the solutions. If you divide here by 3, you will have theta to be 0 over 3, here pi over 3, and here 2 pi over 3. And here 3 pi over 3, which is just pi. So these are the 4 solutions to this trigonometric equation here. Now, after solving parts A and B, we will continue to solve parts C and D. So we'll start now with C. Here it says, if x is equal to sine pi over 9, show that this cubic equation is correct. Now, you might say, what do they have to do with each other? Here we have sine and here we have a cubic equation. Now, of course, it has to do with part A. When you replace this x here in part A, you will get this equation. But how can we do it? Because keep in mind also pi over 9 is not a main angle in the unit circle. So we will replace this sine everywhere in this equation. Here, as you see, also sine. If you compare this with this, theta is equal to pi over 9. So theta here is equal to pi over 9. Later, as you see, I need to multiply it by 3 to get 3 theta. So 3 theta will be 3 pi over 9, which is pi over 3. So if I replace this x here, what will I get is this. On the left, I get sine 3 theta, which is, as we said, pi over 3, top right here. Then equals, here we have 3 sine, here we're doing here 3 sine theta. So 3 sine, look, for now, for the first time, I will write as it is. I will write this here, sine pi over 9. Minus 4 sine cubed of the same angle. That means, now see here, pi over 3, or here, sine pi over 3, as you know from the unit circle, is square root of 3 divided by 2. So I replace it by root of 3 divided by 2 equals, don't forget that sine pi over 9 is x. So this will be x, and therefore this is here x cubed. So it will be 3x minus 4x cubed. I need to multiply this equation by 2 everywhere. If I multiply this by 2, I'll get only square root of 3. The 3x will become 6x, and then the 4 will be 8, so 8x cubed. Now, in the resulting equation, move all of these to the left. The negative 8x cubed will become positive 8, and then minus 6x, and then plus root of 3 as it is equals 0. And as you see, really, it's the same exact polynomial we need to show. So with this, we did part C. Now, after we solved part C, we'll solve here part D. That has itself 2 parts, 1 and 2. Now, part D is really here interesting because it's like different topics. It will connect trigonometry here with polynomials. Here, part 1, as you see, it says, show that sine 2 pi over 9 and negative sine 4 pi over 9 also satisfy the same cubic equation here. So to do part 1, which is this, we'll do the same exact work we did for the pi over 9, except for the fact that here theta will be 2 pi over 9. So when we replace it here, 3 theta, if you multiply this by 3, by the way, it will be 6 pi over 9, which is 2 pi over 3. So now they're telling you like this. If we assume now this one here to be x, this sign to be x, for example, then prove that the cubic equation here correct like we did in this part. So nearly similar work, but the angle here is different. So to do it now in part D, here I will replace the sign here. As we see, sine 3 theta or 3 theta becomes this. So it will be sine 2 pi over 3 equals, keep 3. Here, by the way, I will replace sine theta like I did here in part C. But here, it will be sine, it will be sine 2 pi over 9. Here I can replace it by x immediately. So I will have 3x minus 4, the same sign. So 4x cubed. In the same way as we did part C. Now keep in mind also, sine 2 pi over 3 is also square root of 3 divided by 2. Perfectly like this. So as you see, really, the two equations here are identical, which means if we rearrange this, it will be definitely and similarly 8x cubed minus 6x plus root 3 equals 0. We did it now for this angle, but now we'll do the same for negative sine 4 pi over 9. But unfortunately here, it will not be completely similar to what we did in the first two examples, because here we have negative. So you have to think about how to get rid of negative in the front of the sign. You studied, or you should have studied in trigonometry, something like sine is an odd function, which means sine negative x is negative sine x. The negative can go out. This is an identity in the sine function. Which means if I apply it to this, negative sine 4 pi over 9, it should be the same as sine negative 4 pi over 9 here. So we will do the same work, but here the theta, if we use this, the theta will use this here because, as I told you, this with the negative is the same as this. So theta here will be negative 4 pi over 9. Negative 4 pi over 9. If you multiply by 3 theta will be negative 3 by 4, 12 pi over 9, or 4 pi over 3. Now, so if you replace it here in the same way as we did in the previous two examples, we'll get, so we will get here sine, as we said, sine this 3 theta, negative 4 pi over 3, equals 3 sine theta, which is supposed to be this here, x. This will be now sine theta. Our theta is negative 4 pi over 9. So 3 theta will be this, as we said. So this will be x. I will replace x minus 4 sine cubed, which is again x cubed. Again, by the way, sine 4 pi, negative 4 pi over 3 like this is also root of 3 over 2, positive root of 3 over 2, which means if you rearrange it, it will be the same as the previous two cases, like this and this. So this is also here root 3 over 2. If you move and rearrange, it will be also 8x cubed minus 6x plus root 3 equals 0. So as you see, three different signs, this and this and this, satisfy the same cubic equation. In part 2, it says find the exact values of this sine multiplied by sine multiplied by sine. Now, this is no calculator. Never think that we need to look for trigonometric identities or whatever to solve this. No, it's directly related to the polynomial or the cubic that we did here. See here what we did in part C and part D1. We proved that sine pi over 9 and sine 2 pi over 9 and this negative sine 4 pi over 9, we proved them all to satisfy the same equation, which means they are solutions or roots to the same cubic, which means here they require the multiplication of the roots or the product of the roots. Now, in our case, keep in mind that the roots are, in our case, this and this and this, including the negative. So sine pi over 9, I'm multiplying now the roots, times the other one, which is sine 2 pi over 9, and then the other one, which is negative, as you see, negative sine 4 pi over 9. Keep in mind here something very important. We have a cubic polynomial. As you know, in polynomials, because we have the degree 3, then it has 3 roots. And because we proved that these satisfy the cubic here, it means these are the 3 roots. And these are, of course, different. They are distinct from each other. So they are the only 3 roots available for this. As you have probably studied in polynomials, the product of roots in polynomials, here as you see, if you have a polynomial, the product of the roots is negative 1 power of n, the constant term, dividing by the leading coefficient an. Here n is the degree of the polynomial, which is in our case 3, because our function is cubic. So it would be negative 1 power of 3, which is negative. You divide the constant term by the leading coefficient. So here if we go back, the product here, to get the product, we divide. We have minus first. Don't forget the minus 1 power of 3. Then we have, or we divide the the constant term, which is here the term that's not multiplied by any x. Here it's root of 3. Divided by the leading coefficient, which is in our case the coefficient of x cubed 8. So this is the product. But keep in mind, they need sine 4 pi over 9. Here we have negative. We multiply the 3 roots because this is the root. It has negative, as we proved. So to eliminate the negative here, we have to multiply both sides by negative 1. So by multiplying by negative 1, we will get, if you multiply this side by negative, then you'll have here positive sign, and the negative here will be eliminated. So the product needed in part D is root of 3 over 8. The answer to this is root of 3 over 8. I hope that you have got lots of ideas, plenty of ideas how to manipulate, how to do algebraically from this question. Please hit the like button and consider subscribing for the channel for more IB Math videos to come. Thank you for watching.